Hello everyone, this is lesson 4.7 on hypotenuse leg and CPCTC. So HL is the fifth of our triangle congruence theorems. So far we've got side, side, side. And remember, these are shortcuts for proving that triangles are congruent. So instead of proving that all three sides and all three corresponding angles of two triangles are congruent, you only have to prove a combination of three different things, but the specific combinations that work are these ones. So side, 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 angle, side, angle, and angle, angle, side. So the order, consecutive order matters. If for angle, side, the side is in between the angles. For angle, angle, side, the side is not in between the angles. Now, we looked at the one that was SSA and found that it could make if you didn't know the other side length and the other two angles, if you only know these three things, it could have made an obtuse triangle or an acute triangle. So this wouldn't guarantee that the two triangles would be congruent. However, if you know that this angle is a right angle and that you have a right triangle, two right triangles, then that will prevent you from not knowing if you have an acute or an obtuse triangle on your hands. So we have this thing called HL. It's a specific case of side-side angle where it is a right triangle. And then we'll talk about CPCTC in a minute. But for now, if the hypotenuse, this is for hypotenuse leg, if the hypotenuse and leg, so the hypotenuse and one of the legs of one triangle are congruent to the corresponding parts of the other, so the other hypotenuse in one of the legs. So note, you have to know the hypotenuses are congruent, and you have to know one of the legs are congruent. It's not good enough to know that the two legs are congruent. If the two legs are congruent, then it would be side angle side. And also, if it's just the hypotenuse or just the leg, then it might be like angle side angle or angle angle side if you have another angle. So just because it's a right triangle doesn't mean that you're going to use hypotenuse leg, but it is an option if you see side, side, angle. Then that would be hypotenuse leg because the angle is a right angle. Okay, so to use hypotenuse leg, just a summary, you must show that these three conditions are met in your proof. You have to show that there are two right angles, and you have to show that there is one pair of congruent hypotenuses and one pair of congruent legs. So what additional information would you need to prove the triangles are congruent by hypotenuse leg theorem? Well, here you already know one of the legs, and you know that you have a right angle because it's marked with a right angle symbol, but you do still need to know the hypotenuse. So you need to know that RS is congruent to VW. For number 2, for these two triangles here, you have the leg, you have the right angle, but you need to know that the hypotenuse is congruent. And we can say that here because they're overlapping. So by reflexive property, WY is congruent to YW. Okay, so number 3. For number 3, we need to know that there's a right angle here. So it would be angle C and F, because then these two would be your hypotenuse and then these two would be your leg. So angle C and angle F are right angles. All right. We will have a proof that you'll learn a little bit about altitudes with. So it says OF is an altitude in circle O. So let's write that for our first statement. OF is an altitude in circle O. And that is given. So the definition of an altitude is that it is perpendicular, it goes through a point, so the point would be O, and it's perpendicular to the side that it intersects. So it's perpendicular here to segment EG. So we can say that OF OF is perpendicular to EG. And that's definition of an altitude. All right, so since we have two perpendicular lines, by the definition of perpendicular lines, they form right angles. So the ones we're interested in here are EFO and GFO. So angle EFO and angle GFO are, running out of room, right angles. That's the definition of perpendicular lines. Okay, and then the next thing we're going to do is sort of an optional step. Like sometimes you see it in proofs, but sometimes you skip it. Like really all we need to know are that they are right angles. But sometimes you go a little bit further and say that angle EFO is also congruent with angle GFO, because since they're both right angle, it's by the right angle congruence theorem, they're congruent. Right angle congruence theorem. And this comes from the other theorems where you're really supposed to say like all three of the parts that are congruent. So we're just going one step further and saying that not only are they right angles, they are also congruent. So we have that piece of information. We still need, if we want to use hypotenuse leg for these two triangles, then we still need the hypotenuse and we still need a leg. So you can see that the part that overlaps is EF. So you know that by the reflexive property, OF is congruent to OF, and that is reflexive property. And then the other thing about circles is that the radius of a circle is always congruent. Circle O is how you name the circle. The way you name a circle is by naming the center. So O is the center of the circle, meaning that OE and OG are both radii, so they are congruent. So OE is congruent to OG because all radii in a circle are congruent. So those would be your hypotenuse. So now since the leg and the hypotenuse are congruent, we can prove that the two triangles are congruent. So EFO and GFO. So the triangle EFO is congruent to triangle GFO because of the hypotenuse leg theorem. Now you're probably saying, well, Mrs. Billig, that's actually not what we were trying to prove. We were trying to prove that EF and FG are congruent. So we're going to use the mnemonic that we had at the beginning of the lesson, CPCTC. That stands for corresponding parts of congruent triangles are congruent. That means if you can prove that these two triangles are congruent, then you can prove that all of the other corresponding parts that we haven't named yet are congruent. So you might think that, okay, because this is an altitude, it also splits EF and FG in half. Well, that's not necessarily true. It is true here because this is a circle, but we're proving this. So we're proving this property of an altitude in a circle. Okay, so you're going to learn more about properties of altitudes and circles when we learn about circles in chapter 10, but we have proven this property now. So EF, we can say that EF is congruent to GF because of CPCTC. Since EF and GF are corresponding parts of those congruent triangles, we know that they are in fact congruent. We'll learn more about this on the next page. All right, so here's another proof. So angle P and angle R are right angles. Just use an abbreviation here. That is given. and PS is congruent to QR. And that's given. I'm going to mark the PS and QR. Okay, so we also know that QS overlaps, so we can say that QS is congruent to. Now, when you name it the other way, you should be naming the vertices in the same order. So Q and S would actually be reversed for the other triangle, so SQ. And that's reflexive property. And then after that, we can, we're probably gonna, you could do this in 4 steps, but if we have 5 steps here, they're probably wanting us to say that angle P is congruent to angle R by the right angle congruence theorem. And then finally, we can say that triangle PQS is congruent to triangle RSQ by hypotenuse leg. Since these are both right triangles, the hypotenuse in one of the legs are congruent. All right. So more on CPCTC. It says once you conclude 2 triangles are congruent, then you can also conclude that corresponding parts of congruent triangles are congruent. So CPCTC can only be used for proving sides and angles congruent after, it says that here too, after you prove that the triangles are congruent. Do not use it for proving that triangles are congruent. It says corresponding parts of congruent triangles, not corresponding triangles of congruent triangles. So here this is a good way to show the use of CPCTC. You've got the triangles.
Teachers, just a reminder,
And then,
oh,
sorry for the interruption.
Staff update on Google Meet. We'll start right at 7:35. I shared out the agenda.
Okay, so CPCTC comes after you prove the triangles are congruent to prove that U and K are congruent. All right, so then we have 2 more proofs. The next ones are bonus, half a point each. Okay, so for this question, we know that GB and GD are congruent. That's given. And we also know that GU bisects angle DGB. And that's given. So by the definition of an angle bisector, we know that DGU and BGU are congruent. So angle DGU is congruent to angle BGU. And we also know that GU is congruent to itself by reflexive property. So because now we know that 3 parts are congruent, we can prove that the triangles are congruent. So triangle BGU is congruent to triangle DGU. And that would be side, angle, side. So this is not hypotenuse leg because we haven't shown that these are right angles. So it'd be side, angle, side. And then now that we know the triangles are congruent, we can prove that the base angles here are congruent, hence why we are proving the isosceles base angles theorem. So that's CPCTC. This says that if you have an isosceles triangle where the legs are congruent, then the base angles are congruent. Now the converse of that says if you know the base angles are congruent, so you're starting with angle B and D, then you know that the sides are congruent. So first, let's say what we're given here. The second given is the same as the one above. So we're going to basically be following the same steps here. So angle DGU congruent to angle BGU, and that's definition of angle bisector. And then reflexive property. But now the reason is going to be different. So triangle DGU is congruent to triangle BGU. The reason for these triangles being congruent is different because the side is there's only one side and there are two angles, and the side is not in between the two angles that are congruent here. So this would be angle, angle, side. And then finally, CPCTC, we can prove that the legs are congruent. So that's the converse of the isosceles space theorem. Okay, the next page is bonus, 1/2 point each if you get them correct. So that is the end of this lesson. I hope you have a great day.